Hello, viewers. Welcome to another edition of Higher Mathematics. My name is Ekele. You can follow me up on YouTube for more videos. Today we are going to be looking at solving simultaneous equation using matrix method. Matrix method for solving three sets of simultaneous equation. Don't forget that a matrix is a set of real numbers or elements arranged in rows and columns to form a rectangular array. Now there are different approaches to matrix. We will not go into those elementary parts, definition of matrix, types of matrices, multiplication of matrix, division of matrix, addition and subtraction of matrices. We are going to be applying all these procedures, all this system into solving a set of simultaneous equation using matrix method. So let's start. If you look at this problem on the board, it said solve completely. We have equation 1, we have equation 2, and we have equation 3. We have to look for x1, x2, and x3 simultaneously. That is at the same time, simultaneously. So let's start. Solution. The first steps after rewriting the question, we write the problem using the formula AX equal to B. It's a standard acceptable formula we are going to be using to solve this equation, where X becomes A inverse multiplied by B. When you make X the subject of the formula, you have this. X is the unknown, which is made up of x1, x2, and x3. A is a 3 by 3 matrix, and B is the constant of the matrix. So what we're going to do is that we're going to write them out where X is made up of x1, x2, x3, which is what we are looking for. Then we have B, which is a constant. B is 4, 2, and 1. 4, 2, and 1. This is B. Then we have A. A is, now to get A is a 3 by 3 matrix. You bring out the coefficient of each of the variables. X1 has a coefficient of 1. X2 has a coefficient of 2. X3 has a coefficient of 1 in equation 1, like that. Here we have 3 minus 4 minus 2, 3 minus 4 minus 2. Then here we have 5, 3, and 5. You bring out the coefficient of each variable in each of the equation. So we have here 5, 3, and 5. So this has formed a 3 by 3 matrix from this equation. So we're going to be solving this 3 by 3 matrix. That is why it is applied in this formula here. X is the unknown that we are looking for. A is the inverse of a 3 by 3 matrix. Then B is the constant, which is the values here. So I'd like to clean the board and continue. The next thing is that we write out our 3 by 3 matrix. A is equal to 1, 2, and 1, 3, negative 4, and minus 2, 5, 3, 5. So which is this? Then we find the determinant of A. The determinant of this matrix is gotten by you put down 1, then you close here and seal here. Draw a horizontal line across 1 and a vertical line across 1. You are left with 5 times minus 4, which is minus 20, and 3 times minus 2 plus 6. Then the next one is this, minus 2, because you are using the principle of plus minus plus. Minus 2, bring it out, draw a vertical line across 2, and draw a horizontal line across 2. You have 5 times 3, 15. 15 minus 5 times minus 2 is 10, which is plus 10. Then the third one is plus 1. Draw a vertical line across 1 and draw a horizontal line. You have 3 times 3, 9. 9. 5 times 4 is 20. 9 plus 20. So from here we have minus 20 plus this is minus 14. Minus 14 times 1 is minus 14. Then 15 plus 10 is 25. 25 times 2 is minus 50. 9 plus 20 is 29. 29 times 1 is 29. So when you solve this math, minus 14 minus 50 is minus 64. Minus 64 plus 29 is negative 35. So minus 35 is the determinant of, so the determinant of the matrix is minus 35. The next thing is to get the cofactor of a 3 by 3 matrix A. The cofactor C is gotten by A11, A12, A13, A31, A32, 21, sorry, A21, A22, A23, A31, A32, and A33. So we use this formula to get the cofactor. A11 means element 1, which is at the first row and first column. A12 is element 2 in this matrix, which is at the first row and second column. That is the meaning of A12. So we are going to get the cofactor using the minor. Now to get the cofactor of 1, element 1, we write it out, 1, and 1 has a sign of plus. You bring it out, and when you draw a vertical line across 1 and a horizontal line, you're going to have minus 4 times 5, which is minus 20. Then here you're going to have 3 times negative 2, which is negative 6. Then with the other negative sign become plus 6. So if we do this, minus 20 plus 6. So if we do this, minus 20 plus 6 will give you what? Minus 14. This is the value for A11. So A11 is this, which is 1 here. Now this one, minus 14 takes the place of this one. If we do it for each and every one of them, without wasting time, we're going to have a cofactor of C equal to A11 is minus 14, A12 is minus 25, A13 is 29, minus 7, 0, 7, 0, 5, and minus 10. So this becomes the cofactor. cofactor of matrix A. Is a cofactor of matrix A. The cofactor is gotten from the minor. We look for the minor of each of these. So the next thing is to find the transpose of the cofactor. Transpose of the cofactor, which is the adjunct. Adjunct of A. The adjunct of matrix A is gotten by the transpose of the cofactor, which is this. Now, how do we get the transpose? The transposition of a matrix means make the first row the first column. If you do that, this is the first row. This is row and column. The first row is minus 14, minus 25, and 29. You write it out. Minus 14, minus 25, and 29. The second row is this. You write it out. Minus 7, 0, 7. The third row is this. You make the third row the third column. 0, 5, minus 10. So you have transposed this cofactor, and the transpose of a cofactor is equal to the adjunct of a matrix. So we have gotten the adjunct of matrix A, we have gotten the determinant of matrix A. So the next thing we are going to find is the inverse of matrix A. So I will clean this side so we can continue. The inverse of matrix A, given by this formula, is adjunct of matrix A all over the determinant of matrix A. This is the standard formula for finding the inverse of a 3 by 3 matrix. So, which is equal to, what is the adjunct? The adjunct of A is this, and the determinant. Don't forget, we calculated our determinant to be like a minus 35. Don't forget where we started. Our determinant was negative 35, and this is our adjunct. So we'll bring them together. We are going to have 1 over, this is inverse, 1 over minus 35, bracket, the adjunct, which is minus 14, minus 7, 0, minus 25, 0, 5, 29, 7, minus 10. So this is what we are going to have. Then don't forget, then we now say but, from our initial formula for finding x is equal to A inverse times B. A inverse times B. Don't forget this formula. We started with this formula. This is the formula you use to solve a 3 set of simultaneous equations using matrix method. This is the formula. So now we already have our A inverse and we have the value for B. Don't forget the value for B, which we have from the initial equation, is 2, 4, 2, minus 1. 4, 2, and negative 1. B is a constant. So we're going to use it to multiply this. So I'll clean here and continue. So we're going to use it to multiply this. Therefore, x becomes minus 1 over 35, bracket, negative 14, minus 7, 0, minus 25, 0, 5, 29, 7, negative 10, times the value for B, 4, 2, minus 1, 4, 2, minus 1. So this is what we're going to have. So what we'll do is to times this and this. This matrix, this 3 by 3 matrix, and this a column matrix together. Our result will now multiply this. So we're going to have this. So let's do the first one. The first one is minus 14 times 4, minus 7 times 2, 0 times negative 1. So if we do minus 14 times 4 is what? Minus 14 times 4, we're going to have 4 times 4, 16. 4 times 4 is 16, write down 6, carry 1. 4 times 1 is 4, plus 1, 5. So minus 14 times 4, you have 56. Minus 7 times 2, you have minus 14. 0 times minus 1 is 0. So 56 minus 14, we are going to have 2 and 4. We're going to have 42. The first one will be 42 here. So minus 14 times 4 is equal to minus 56. Then minus 7 times 2, minus 7 times 2 is equal to minus 14. Then 0 times minus 1, 0 times minus 1 is equal to 0. So we sum this together, you have minus 70. So we're going to do this for all of them. When we do this, we're going to have, what we're going to have is x is equal to minus 1 over 35. When this multiply this, which I did, is minus 70. When this second row multiply this column matrix, you are going to have minus 105. And when this third row multiply this column matrix using the same procedure I used for the first one, you're going to have 140. For the sake of time, you're going to have this. So this has become a scalar matrix. Now 1 over 30, minus 1 over 35 will times minus 70, minus 105, and 140. You're going to have x to be equal to minus 70 over 35 over minus 35 minus 105 over minus 35 and 140 over 30 minus 35. So when we do this, we are going to have this 70 divided by 35 is 2. Minus will cancel minus, becomes plus. 105 divided by 35 is 3. Minus will cancel minus. 140 divided by 35 divided by minus 35, this one gives minus 4 because of the negative that is there. So this becomes our answer. Therefore, x1 is equal to 2, x2 is equal to 3, and x3 is equal to 4. This is the solution to this equation. This is the solution to this equation. If you want to check whether you are correct, let's check whether you are correct. To check, we want to check, we are going to have x1, let's write check. Check x1 plus 2x2 plus x3. We are going to substitute this value here and see whether it will give us 4. x1 is 2. We have 2 plus x2 is 3. 2 times 3. x3 is minus 4. Don't forget, x3 is minus 4. Minus 4. So we have 2 plus 2 times 3 is 6. Plus times minus is minus. Minus 4. So 2 plus 3, 2 plus 6 is 8. 8 minus 4 is equal to 4. So you can see that it's correct. When we substitute the final answer into this problem, it gives us the constant 4. So that shows that our answer is very correct. This is how to use matrix method to solve a 3 by 3 set of simultaneous equation. This is a matrix method. Don't forget, there are other methods of solving this particular equation. We can use the Gaussian elimination method to solve this particular equation, and it will give us this same answer. We can also use matrix method to solve this set of simultaneous equation, and it will also give us the same answer as you can see on the board. We can use the determinant method. So in our subsequent videos, I'm going to be telling you how to use the determinant method to solve this equation and the Gaussian elimination method. Please don't forget to like and share this video. You can follow me on YouTube for more videos by clicking the link above. Thank you.